This is part 2 of the episodes with Dr. Jennifer Kasten. Part 1 was all about what we've learned in the last 11 months about COVID. And this episode is all about the SARS-CoV-2 vaccines. We discussed when we can expect full FDA approval rather than emergency use and what that entails. How she arrived at the declaration made during the episode that she believes the vaccines will last 2 years. Why she thinks the vaccines provide sterilizing immunity, meaning you can't pass it on, and the potential pathophysiology of thrombosis after the J&J and the AstraZeneca vaccines. How the mRNA vaccines work, apparently muscles are just for show, not immune responses, and an update on the pediatric vaccines. I'd also like to mention that I'm now part of a network, the Doctor Podcast Network, where all of the podcasts cater to a physician audience. For instance, Mike Woo-Ming, aka Bootstrap MD, hosts the Physician Entrepreneurs Podcast, so be sure to check that one out.
Welcome to the Physician's Guide to Doctoring, a practical guide for practicing physicians. Dr. Bradley Block interviews experts in and out of medicine to find out everything we should have been learning while we were memorizing Krebs cycle. The ideas expressed on this podcast are those of the interviewer and interviewee and do not represent those of their respective employers. Those on this podcast accept no liability for the outcomes of medical decisions based on this information. As the radiologists like to say, clinical correlation is required. This is not medical advice, and this does not constitute a physician-patient relationship. If you have a medical problem, seek medical attention. And now, here's Dr. Bradley Block.
Before we get into the show, here's a quick message from MR Insurance, a small business that helps physicians with their disability insurance needs. Michael L. Relvis is a CFP professional and insurance agent committed to helping physicians nationwide with their term life insurance and disability insurance needs. He provides an objective, transparent, and education-focused process that aims to help physicians make prudent decisions and avoid overcomplicating things. He exclusively offers own occupation disability insurance policies for residents, fellows, and attending physicians. We know he'd be happy to help you with whatever your needs are. You can find Michael at drpodcastnetwork.com/mrinsurance or contact him at 800-817-4522. That's 800-817-4522. Dr. Kasten, thank you so much for coming back on the podcast again.
Well, thank you, Brad. I feel like I'm a comet orbiting. I just can't break free of your gravitation field. I just keep coming back.
I get that a lot. So,
well, you're very magnetic.
Which is I thought it was just because of my mass.
Well, yeah, you've got a lot of space trash to you, so that's part of it too.
Let's talk about the vaccines. So today's talk is going to be about the vaccines. Which is the best?
The one that is in your arm.
Okay. I got a little of all of them, so I'm not able to. No, I didn't. But you got the AstraZeneca vaccine. How did that happen? How did you end up getting that?
I mean, I wish I could tell you it involved like being whisked away on a supersonic jet to a country that offers the AZ vaccine. It's much less interesting in that I volunteered to be in a study and was accepted. And so was actually one of the pilot people in the United States on whom the vaccine was tested. So yes, I was vaccinated back in November.
Wow. We actually looked to get the kids enrolled in a study. Mm-hmm. They're all under 5. Mm-hmm. And we live in New York. So I'm like, there has to be one of the academic institutions in New York. No, closest place was Boston. So we are not driving to Boston to enroll them in a study.
That's fair. Yeah. I mean, you would if you loved them, of course.
Yeah. No, they're there for my entertainment, which is what my father said to us.
Your selfish genes being passed on. Yeah.
So before we get to the vaccines themselves, let's talk about the process. So how is the FDA process of approval different from the typical process?
Currently?
Yes.
Because the process hasn't changed. It's not like the FDA's changed anything. But what they've done is authorize all of these vaccines under an emergency use authorization, an EUA. Okay. So that does not mean that they still won't go through the full vetting FDA approval to be finally approved. They will. And in that stage, the FDA independently verifies all the data that the companies report into them. So that takes many, many years. And obviously they made the very sensible decision to say, hey, you know what? We don't really have years here. Looks pretty good. Let's give it a go. There might be some downside, but certainly the upside is greater. So that's where we are right now. So the EUAs are granted based on data the company reports in, the manufacturer reports in, whoever it is, but they're not independently validated.
Got it. So what is it that needs to happen? Why does it take years?
Well, just
for them
imagine
to get full off.
Yeah, because the FDA has to investigate each of these vaccines. They have to see how they perform both from a safety profile as well as from an efficacy standpoint in the natural course of things out in the wild, in the population. So how many people report adverse events? They'll also conduct focused and much more intensive scientific inquiries into the efficacy. And then there's the field trial, like I was saying, of how does the vaccine perform in the wild? What's the protective effect? And of course, everyone is very interested to see, well, we know what the company reported in their trials, and we have no reason to think they were being disingenuous, but they might have an incentive to favorably report data. And that doesn't mean that their data is just like written down on a piece of paper, like, yes, Moderna, 95%, push it across the table. Do you accept FDA? We do. No, they report actually everything they've got. And so the FDA can look it over and do the analyses and everything. But as far as independently verifying each of those inputs, that obviously takes quite a long time.
So then what's the timeline for it to get full authorization? And why is it taking years?
Well, I don't know. I mean, I don't know what the FDA's internal timeline is here, but okay. I know that prior to this pandemic, the fastest approval was for a Zika virus vaccine, which never really went out clinically. And that took, what was it? I think it was 3 years, roughly.
The best we have to hope for would be 3 years. Because it's interesting. We had...
Well, I don't know that. No, I don't know if that's true at all. I mean, it might be much more expedited because it's obviously of immensely more significance and public concern. And so they probably have many more people dedicated to it and everything else. We're all speculating on the FDA's inner workings here, and neither of us is privy to them. But yeah.
Because I had an interview with a lawyer previously who said that there's no legal precedent for mandating a vaccine that's EUA, right?
Right.
So, and it would put someone on dicey legal grounds to mandate it. That being said, recently I've heard from people that some institutions are mandating it. So we'll see how that plays out.
Yeah. Now your lawyer knows better, but from what I understand, private entities of any kind can mandate vaccination from an employment standpoint.
Can.
And sir, I mean, you and I are both doctors, I think, unless you just put those letters after your name to look cool.
I don't even know what they stand for.
All right. I forgot to myself. MAD.
Right, but those are not, like the flu vaccine is not authorized for emergency use.
No. So the EUA bit is obviously the unique bit, but places of employment can certainly mandate vaccination.
Yeah, but that was her point. Her point was because the EUA status, there's no legal precedent for mandating a vaccine that hasn't been fully approved, but has only been approved or authorized for emergency use. So we might end up, like before we can mandate it for medical school, mandate it for high school, mandate it for elementary school, it needs to be taken off EUA status and fully authorized.
Yeah, no, I mean, I don't know. Lawyers are obviously real keen on precedent, and sometimes there isn't precedent because the last time we had a pandemic, we didn't have vaccines. That didn't exist, right?
Yes.
Except for, I guess, the Jenner smallpox vaccine.
Cowpox.
Yeah, cowpox. Even if you have any milkmaids handy, then great. But so, precedent is of interest to them, I think less so for people in science.
Yeah.
We certainly build on foundations, but want to discover something new and break new ground. And I think all of us would say this is, to use every CEO in the country's favorite term, an unprecedented situation that we find ourselves in. And not only do we have a global pandemic that's sloshing around the world, infecting millions, if not billions, we also have an effective tool to fight it, which is the vaccine.
Yes.
So why not use it?
My rights, my individual rights.
No, and so no one here is saying that we want to trample on individual rights. And autonomy and self-determination are foundational principles in this country and many others.
Yes, coming from someone who, chops up trees in the woods.
Yeah.
Like a
pioneer. Trees have no say in the matter, but yeah. But still, at the same time, one chooses to be employed at a particular place.
Yeah.
So if you don't like their vaccination policy, you could choose to be employed elsewhere. And so that's somewhat in keeping with the notion of individual rights.
Self-determination.
Yeah.
So what does the real world data look like for the different vaccines versus what we were told by the manufacturers?
Well, I guess the biggest, most recent bit that's come in has been the breakthrough infection rate, which is 5,800 cases plus a few out of the 60-odd million Americans who have been vaccinated. Now, remember, that's over a short interval of time as well. So it's not like those 60 million people for life, we're only going to have 5,800 infections in those 60-odd million, right? So it's over a short window of time, about 2.5 to 3 months. But it's still a very, very low rate, and it's quite encouraging. It's certainly lower than the data reported in the trials by the manufacturers. So great. But like I said, it is over a small window of time.
Yeah. What about the longevity, right? Everyone's surmising about the longevity, right? Is it going to last? And so now we know it lasts at least 6 months.
Correct.
And of course, some of the public misinterprets it. It only lasts 6 months, but right, we know that it lasts at least 6 months. How long do you think it's going to last?
I think 2 years.
2 years. How'd you arrive at that number?
I arrived at that number because I'm a time traveler from the year 2023.
Where nobody has immunity anymore.
Where there's 6 survivors. Yeah, and it's a paradise, actually. But we are basing that largely off of data from the other baddie coronaviruses. So SARS-1 and MERS in particular. And the overall mutation rate, which seems to say probably in about 2 years, some variant's going to emerge that's going to have some kind of escape velocity, be different enough that the vaccines won't cover. And then coupled with that, like I said, from the other known coronaviruses, which this did not happen because they were eradicated in the wild, so to speak. They didn't propagate and they didn't mutate. They died out. But we can look at antibody titers in people who were infected with those viruses and see that really by about 2 years, the titers are low enough that they wouldn't have too much of a protective effect.
What about T-cell immunity?
I don't know the specifics of T-cell immunity for those viruses, for SARS-1 and for MERS, but they obviously work in concert with each other.
Okay.
So, go ahead.
So one thing that the CDC was reluctant to say was that you can, if you get vaccinated, you can still, we don't know yet if you can still transmit the virus, right?
Okay.
Like sterilizing immunity versus non-sterilizing immunity. So what do we know about that yet? Is this sterilizing immunity? Can we say that if you get vaccinated and then you're exposed to someone, but you don't get sick, that you're not going to be transmitting it? And how do we know that it's someone who's not an asymptomatic carrier, like we're seeing in the unvaccinated population?
Well, first, I think the CDC was absolutely right to warn people that this is possible. And they should be thinking about it. Because the last thing anybody wants, especially if the public is jittery about trusting the CDC and public health authorities, if they feel like they've been burned, the last thing you want is false certainty and false assurances. And then, we did know this was a theoretical possibility. We just didn't want to worry you at the time.
Right. You don't want to have to walk something back. But the messaging also needs to be clear that we just don't know yet.
We don't know yet.
And I think the messaging was a little, it's just... Yeah. What people heard, what they said versus what people heard was that it doesn't prevent you from transmitting it. We just don't know yet.
Yeah, which is too bad because I think they did say that. I think they did say we don't know. But people do run with worst case scenarios sometimes. We don't know yet. How can we possibly know that yet? How long has the public been mass vaccinated? Well, they're not yet. I mean, at this point, you and I are talking again on April 20th, 2021, about 50% of US adults have received at least one dose of vaccine, which is awesome. But if we think that the actual HIT, herd immunity threshold, is somewhere north of 70%, maybe even higher when you start discussing the variants, which of course we should because they're rapidly becoming the dominant. They are the dominant strain now. It might be 80%. So we're not there yet. And we just don't know. We don't know if all of the transmission that we're seeing, which we're seeing quite a lot of course, who is that coming from? What's the source? Who's originating it? from the biology of the virus, the biology of the vaccine, the biology of the host response, I think we should be pretty optimistic that people who are vaccinated are not transmitting it, because we know that there's excellent neutralizing antibodies. We know that there's good T cell immunity as well. We know that viral loads are very, very, very low, very suppressed, because these neutralizing antibodies are killing all the virus. And so if you remember, there's an innate concept of infectious dose for transmitting COVID. About 1,000 virions, right? 1,000 infectious particles, intact infectious particles, have to go from host A into susceptible person B before they'll kick off an infection. Might be lower with the variants, maybe even as low as 500. But they need to be intact infectious particles, and they need to get into that susceptible person B. And if your vaccine's on board and your immune system's kicked in and it's suppressing things, I just don't see that you're going to have that viral load. And if you had a viral load significant enough to be able to infect others, you'd have, I would think, an equal chance as an unvaccinated person as far as being symptomatic. If you had, I don't see how a vaccine being on board between two people who are at a viral load high enough to spread would change the likelihood of whether or not that person would have symptoms.
Got it. Well, that's encouraging, right? Like, what we should be telling people is it should. So
it should.
Can it prevent me from getting grandma sick? It should. We just don't know for sure yet.
We don't. And you can't. You can't. Just like the question of how long does immunity last?
Yeah.
Well, at least as long as it's been around, right? Yeah. But we can't dial it forward.
Yeah.
It's unknowable. Unless you have a TARDIS.
A what?
A TARDIS.
What's a TARDIS?
From Doctor Who.
No.
It looks like a post box.
Got it.
But it can travel through time.
Okay.
Anyway. Or telephone booth, not a post box. Sorry.
That's what happens when you train in London, right?
Yeah.
You become a Doctor Who fan.
Osmosis, yeah.
Okay, so what's the deal with waiting 90 days after COVID to get vaccinated? Was that just to free up vaccine? Like, now that we know that if you got sick for 90 days, you can't get it again, or probably can't get it again. Yeah. So we're doing that in order to free up vaccine for people that are vulnerable, or is there some other reason why we're...
Okay. Again, this is unknown. This was unknown at the time. So people just had to make guesses, because how do you know how the public's going to respond to a vaccine, which no one's been given yet? Right. So I think you're right. There might be a little bit of that, but at the same time, the logistics of keeping track of people who are positive cases, who you turn down for vaccination, and then getting them to come back and be vaccinated again, there is some logistic headache there, and there's some chance of escape and not penetrating into the population you like to penetrate into from a public health perspective. So there's a downside to that. I think primarily it was because of what we know of the pathophys of MIS-C and similar hyperinflammatory syndromes in adults. And the thought was, if you inoculate someone who's very recently had COVID and their immune system is like all systems go because they've just fought it off, if you give them another big dose, not of virus, of course, because none of our vaccines have actual intact virus in them, but of something similar enough, you might really knock them over into something that looks like MIS-C. Maybe. Hypothesis.
Got it.
And of course, in our trials, which is the basis for all the data we have to approve any of these vaccines and get them on the market in the first place, anybody who had COVID was excluded.
Yeah.
And wasn't being injected. So we don't know how they would do. That's my guess.
So then what happens if you get the virus between your first and second dose? Do you still get that second, because it seems then you're worried about MIS-C, so maybe you shouldn't get the second dose, and the virus is effectively your second dose. So
the thing is, I don't think they've relaxed this formally yet, but we have so much transmission right now. We still have so many endemic cases that this is certainly happening, that plenty of people are coming up positive right after they got their first injection or whatever else. And they're doing okay. So there isn't like a population level worry necessarily about a hyperinflammatory response. Can it still happen in some people? Of course. And that's always the caveat. Are there any certainties in medicine? besides the inevitability of death. No.
And you being right all the time.
And me being infallible.
Yeah. So having trained in the UK or studied in the UK and being a Doctor Who fan, wanting to get in their time traveling phone booths, what are your thoughts on what the UK did with mixing the vaccines, right? And then other countries that pulled the AstraZeneca vaccine are having people get a second dose with an mRNA vaccine. So what are your thoughts on this vaccine mixing that's happening?
I think, well, first off, it's all reacting to the climate of the time as things are moving along. It's not like any of these decisions are completely irrational, right? I think if you mix an adenoviral vector-based vaccine and then an mRNA vaccine, you're probably not going to have the same booster effect because you might. I mean, I'm not saying it's nil, but you're not going to have quite the same booster effect. Better than not getting a second injection of anything, right? To be honest,
but you're reacting to the spike protein, right? Like whether the spike protein's on an adenovirus or one of your cells, why would it be any different? It should
be. I'm not saying it's nil, but I think there's just something to do with the mechanism. I think, and the fact that there is occasionally, especially the adenoviral vector-based ones, which is again J&J and AZ, there is a cross-inflammatory response where there's a little bit of cross immunity to the scaffolding platform too.
Yeah. You're not just reacting to the spike protein. You're reacting to the cell, but that spike protein is just more
to the virus, the package. Yeah. So, again, it's probably okay. I'm sure there have been at least some preliminary, some things that they said, yeah, it works. It's fine. They injected it into 5 people and like, okay, it works. So we got to do it. But I don't know this. This is speculation.
Yeah.
So again, it's better than nothing, right? It's certainly better than just pulling AZ and not giving anybody anything.
Yeah.
Right? And you have to remember,
you got the vaccine and that's it.
Well, right. And of course, remembering too, that these are nations that have a centralized health service where things are distributed centrally by the government. And it's not like you can just pop down the street to another shop and say, you know what, I want that, and I'm going to pay out of pocket in cash. That's not often an option in every country.
Yeah. Right? Another argument for federalism.
You get what you get. Yeah, federalism. But of course it's free and they have an extremely efficient way of keeping tabs on everybody, which is pretty nice. Yeah. A national EMR, how great would that be? That would be great, right?
Depends on the EMR, because having worked at the VA 10 to 15 years ago, that MR, it was like DOS.
It was like DOS. But when that came out, it was state of the art.
Yeah. Yes. And it didn't matter which one you went to.
No.
Right? Yes. Okay.
The national EMR.
Yeah. So let's talk about the mRNA vaccine specifically, right? Pfizer and Moderna. When you inject
with regards to them, mixing them, because that's what happened to a lot.
Yeah.
We don't know. They're still somewhat proprietary, right? So they haven't reported out, made public all of the technology behind each one.
We don't know the sequence, right?
No. How are they different? I don't know. You don't know. So is there a reason, like armchair speculating, to think that dose 1 with Pfizer, dose 2 with Moderna, or vice versa, would have some demonstrable effect on the immune response one mounts? I don't know.
Maybe they're the same. Maybe the two CEOs got together and were like, I'll show you yours if you show me, I'll show you mine if you show me yours.
Yeah.
And it turns out they're not that different.
Which is a metaphor, I'm sure. Yeah. I mean, one starts with P and one starts with M. So there's that.
Yes.
So anyway, you were going to ask me a question about...
I was going to ask you a question. So what cells do the mRNA lipid-loaded vehicle enter? Does it stay local in the muscle or does it end up spreading throughout the body?
No, muscle cells are useless, man. They do one thing. They're like orthopods.
They point the way to the beach.
Pretty much. With full respect. To all of our orthopedic colleagues who love these jokes. They really do. Do you remember actually in the height of the New York wave in early April of 2020, the NYU orthopedics department, legit, this is not a joke, legit, when all their operations were canceled, turned themselves into the lift team and the proning team?
No.
They did. They just humbled themselves and said, we will prone patients.
What are we good at?
What are we good at?
Stuff.
Lifting stuff. And they went around and they helped all the ICU nurses prone patients.
And then they went and did box jumps somewhere.
Probably.
Between cases.
Yeah. And like those really insane CrossFit pull-ups, where they do like a pull-up every fraction.
Muscle ups. Yep.
Those.
Okay.
Anyway.
So
muscle cells are useless. They don't do anything.
Muscle cells are useless. Okay.
They do nothing except contract. So they certainly don't pump out virus particles or more to the point, virus proteins. So what happens when you get injected intramuscularly? Why intramuscularly as opposed to in the fat? Brad.
Blood supply.
Blood supply. Well done. Yeah, your fat is just kind of useless, right? I mean, we all know that, but it's really super useless here. And it's not very well vascularized, but your muscle is well vascularized. It also is firm, one hopes. It depends how many of those CrossFit pull-ups you've been doing. But it's firm enough so that it makes a nice pocket, and so it kind of all sits there. And then your immune system kicks in, and it starts with the macrophages, and they scavenge. Like, oh God, look, we've got to clean up now. Look at this mess. And so they come in and they do that, and then they stimulate everything else because they're antigen-presenting cells, and they get the leukocytes in. So it's the immune cells that take up the liposomes via their endosomes. And then the mRNA integrates there, and they start pumping out the spike protein.
So then where is that happening?
Well, wherever they go. I mean, a lot of it will be because they migrate in, so it'll start locally, but then they're in the bloodstream, so they go all around.
Okay.
And so, it's akin to, we were just discussing people who might contract COVID after their first vaccine dose or such, and that hyperinflammatory syndrome of people who were vaccinated after actually having real COVID. So, most people will say now, hey, I had a really rough time my second shot versus my first. This is a common thing on social media, right? And this is why, because your immune system was primed after the first dose, you started to make some antibodies and you say, okay, great. And then the next dose comes along 3 or 4 weeks later and they say, we've seen this before. Let's kick into high gear. We're off to the races. And the para-inflammatory response, the para-immune response is just much more pronounced, right?
Yeah.
And so, again, the immune cells, your leukocytes and whatnot, scavenge the virus. They scavenge the liposomes. I shouldn't say virus because that's going to confuse people and make them think that there's actual virus. There isn't. But the liposomes that bear the protein making instructions. And then they circulate in the bloodstream everywhere else in the body. And so you get a local response. You get that sore arm that everyone's talking about because the muscle makes that pocket. The macrophages come in and scavenge, and that's local. The hyperemia, everything else about inflation. Too much Bitcoin. Inflammation.
Dogecoin.
Dogecoin now, of course. You're a Doge guy, aren't you?
I'm a Doge guy.
You know what I've learned all those guys are doing with their profits? They're buying cars at extraordinary markups from video games. Like a car was in Grand Theft Auto or something.
So they're buying the actual car.
They buy the real world equivalent of it, but at a huge markup because within this community of enthusiasts, So anyway, that's what they're doing with their money, in case you're curious.
Oh, that's useful.
Yeah, adding to society.
Yeah, good real contribution. So, okay. And I would imagine the same mechanism of action for the adenovirus vectors, right?
Right. No liposome.
Intramuscular, fine. Systemic, locally within the muscle, and systemic, fine.
And then around. Yeah.
Right. Recently, J&J was pulled because of this issue of thrombosis. And then it was the same issue or similar issue with AstraZeneca, right? Both of these seem to be possibly creating thrombogenic events. Can you speak at all to the potential pathophysiology of that?
I think so. So it works a little bit like HIT, heparin-induced thrombocytopenia, which is what?
I don't know. I haven't put someone on heparin in over 10 years.
Well, as a pathologist, I do it all the time.
You put patients on heparin?
Yeah. Well, it's either that or straight to the leeches, but yeah.
Okay. We had that a couple times actually on free flaps in
I
residency.
bet you have. Oh, for sure. Yeah. It's pretty cool. The pharmacy brings them up in a little box.
Bring in the leeches.
Yeah. Doesn't that make you feel like charmingly medieval?
Yes. Like
and then you were the resident. You had to round on them. I mean, do you have to assess the leeches and see how well they're doing?
There were wound debridements with maggots.
Well, certainly.
But that was the plastic service. That wasn't the otolaryngology service. They did the wound debridements, but we both did free flaps. So either one of us could use leeches. Okay. So, right. So I haven't used heparin in a while. So no, I know what HIT. I know HIT stands for heparin-induced thrombocytopenia. That's all I know about it.
Well, right. So it's an autoimmune response where you have this paradoxical antibody. It's like sort of these paradoxically created antibodies that induce clotting.
Okay.
And this is the purported mechanism. I don't know if there's been I know there's not been an autopsy or tissue study yet. It seems to occur, obviously, much more commonly in women. The case series in the United States of the J&J vaccine adverse events, the lethal events were uniformly in women, I believe, 6 of them. Mm-hmm. And they cause cerebral thrombi mostly, but also elsewhere in the body. So these sort of embolic type stroke phenomena, but they're often in situ thrombi. And it appears to be antibody mediated or immune mediated. So it's like a cross target antibody response. Why? Great question.
Yeah. Any thoughts on why it's predominantly in women?
Well, women make antibodies more than men do, period. Right? They just have an autoimmune diathesis compared to men. And there's all this armchair evolutionary biology about why it might be the case. Something to do with protecting the fetus and being more alert for foreign invaders in pregnancy or whatever else. Who knows?
Yeah.
But it appears to be true. Just at the same time that's true, men also seem to have a worse time of COVID in terms of the hyperinflammatory cascade. Why? Why do they have more of a cytokine storm response? I don't know, but they did.
We did.
I know it's not satisfying, that answer. My firm belief is that J&J would never have been pulled, even though we did have these 6 adverse events, if there weren't two more efficacious alternatives on the market, right? If both Pfizer and Moderna have a much higher reported efficacy rate, and they don't have this yet, at least these adverse events. So let's just shunt everybody over to that.
Right. These decisions aren't happening in a vacuum.
No, but if the pandemic were raging and this was the only vaccine we had, I bet it probably wouldn't have been pulled.
Yeah. In the last episode, we talked about the herd, right? The herd is the whole world. Right? One world, one herd. That herd happens to have children. And right now, FDA approval for 16 and over for Pfizer, 18 and over for J&J and Moderna. So do you know anything about the vaccine trials in kids? I can't remember if I mentioned in this episode or the last episode, but yeah, we looked to enroll our kids, but there was just nothing that was close enough. So are you aware of what's going on with the trials in kids? What are the endpoints they're looking for? And when we can expect some?
I am aware because my hospital is one of the sites.
Great.
And so we've been vaccinated in this area in Cincinnati, children 12 and up for some time now. But as far as the intricacies of the study and their endpoints and when they're reporting out, I don't know, but I feel confident it's going to be fairly soon. As you know, the adolescent data was absolutely superb. Not surprisingly, they did very, very well with the vaccine, with
regards to safety.
And then also there were 0 infections in the adolescent vaccinated cohort, 0. So it looks it looks perfect. Now that might be an artifact of a low N, but still it was 100% efficacy in the way that they've been reporting out. Moderna is now conducting trials for children as young as 6 months. And that I think will probably be on offer by the summer. So anyone with a child at least 6 months of age, certainly by autumn, will probably be able to vaccinate their child.
Really? I was expecting it more like the fall for the 12 and over and the winter for 6 months.
No, it'll be 12 and over probably by May.
Wow.
Well, for sure. I know my own hospital is a site for this.
Yeah.
And we've been vaccinating 12 to 16-year-olds for months now.
Yeah. Amazing. Anything else that you'd like to discuss about the vaccines that you think we haven't discussed so far?
Well, I'm, as you probably know, pretty keen on combating misinformation. And I think most of the people listening to this podcast are doctors because it's called
Physician's Guide to Doctoring,
which is unlikely to attract a lay audience, but you never know. So, I don't think anybody in this listening directly is going to need to be convinced or be worried about particular myths, but they certainly will be talking to patients and relatives who might be. So I think it would be useful to talk about the swirling misinformation climate right now. And it is whack-a-mole. As soon as you knock something down, something else might pop up. But Brad, what have you been hearing from the community, from your patients, about people who are hesitant to be vaccinated, who are not just anti-vax across the board, but this in particular?
Right. There's the blanket, I just want to wait. And they're not really sure what they're waiting for. And they're not really sure why they're waiting, but they just want to wait. There's the people, there's the conspiracy theorists who think that Bill Gates takes control of your bank account when you get the vaccine. There's general distrust. Some people don't want to get the J&J vaccine because of the talcum powder issue with, I think it was uterine cancer. And so now they just don't trust that company. They'll get either one. So it's just this, distrust
ovarian
cancer. Or they don't trust the mRNA vaccines because it's a newer technology. So they'd rather get a adenovirus vector, which is a more tried and true technology. So, they have their reasons.
Yeah.
But ultimately the decision is based on data that they don't have access to, or I guess we all have access to the data.
If you've been listening to us talking about this, we clearly don't have access to it either. So no fault there.
And issues that are ultimately inordinately complicated, right? Like their concerns a lot of times are, it's new, it's not authorized because it's not fully authorized because we don't have long-term data on it. So if they don't have long-term data on it, means I don't know what this thing is going to do to me long-term, and I'm healthy, I take care of myself, I'm at low risk for getting sick. So I'm going to take my chances and I'm going to continue wearing a mask, and I've done well thus far. So I'd rather continue doing it.
Yeah. And so that was a bucket of things to talk about there.
Yeah.
But yeah, I think you've hit on most of the themes. And another one that I've heard that has been circulating around the interwebs has been concerns for women about fertility.
Yes.
But there was a rumor started that the mRNA vaccines in particular, will render women infertile. And we can talk about that. There are concerns from people motivated about abortion, that the J&J vaccine and the AstraZeneca vaccine was developed in cells originally cultured from an aborted fetus. And so people don't like that.
Well, isn't AstraZeneca chimp adenovirus?
Yeah, but how is it the virus cultured?
Oh, got it.
Hundreds of millions of copies of it. They're in HEK cells, human embryonic kidney cells, which are derived from a single female aborted fetus who was aborted in the 60s. And the cells are immortalized and they've been used, forever and ever and ever from her. So that's true. That's a true fact. But at the same time, a lot of people who are very morally uncomfortable with abortion say, well, in a way, this kind of is this fetus's legacy. Her suffering, if you will, is now immortalized, and she's saving the lives of hundreds of millions of people. So that's great. So there's objections, on the other side too. But we can definitely talk about the fertility thing if people want, because I think a lot of doctors, if you hear that in your clinic and you're like, well, would this vaccine make me infertile? Would this be, what? Where would that even come from?
Yeah.
So it came from a post, as many things do, by someone who is not a scientist, who said, wow, the sequence of this spike protein is really similar to the protein sequence for this protein that's expressed in the human placenta. And so if you make antibodies to that spike protein, you're going to make antibodies to the placenta. And if you get pregnant and you start trying to gestate a fetus with a placenta, you're going to attack it and abort and cause a miscarriage. So it's going to render you infertile. You're going to just miscarry and miscarry and miscarry. And so, if you don't know anything about molecular biology or protein stoichiometry, that sounds terrifying, right? That sounds very plausible. You think, holy crap, I'm not going to get this vaccine. That's nuts, right? Well, it's just completely false. It's as false as it's possible to be. It's sort of like saying, because a piano has legs and I have legs, we're the same. It's both legs, right?
Yeah.
They're legs, but they're not really the same. And the sequence homology between those two different things, the spike protein from the coronavirus and the human placenta, are very, very, very different. And there's no chance that the extraordinarily sensitive and the very specific, lock and key mechanism that antibody binding domains have would ever cross-react with the human placenta and would ever cause a miscarriage in this fashion. So that myth is just not true. And if people hear that in their clinic or relatives or Facebook or whatever, I hope they can put that to bed. The one about waiting and seeing, I think many people can say, well, I understand where that's coming from. Sure. The counterpoint there is that the mRNA vaccines in particular are the ones that get the heat for this because they say, oh my gosh, it's new. Well, it's new in the sense that these are the first 2 mRNA vaccines that have ever been licensed and put out there, and are certainly the first 2 that have been injected into millions of people. But they're not that new. They've been in development for basically about between 15 and 20 years. The technology has been in existence for a really long time.
Well, has that been used for anything else? It wasn't Zika?
There's a drug. There have been some drugs that were put out. I think the first one was in 2018. So there are drugs to these orphan diseases that are based on the same principle, mRNA, delivered via liposomes, et cetera. The big hurdle there is kind of interesting technologically to overcome is that they had to pegylate the lipid because the lipid in and of itself, just making a ball of lipid and injecting it into people is actually kind of toxic.
It's not going to make it into the cell.
No, and it's toxic. It's highly charged and it'll make you sick.
Okay.
So they had to pegylate it to be able to, overcome that, which is kind of interesting. So just from a yay, progress of science overcoming.
But that was the big hurdle, and that had already been overcome.
And it was
just a question of
leapt over.
Yeah.
Yeah. But like I said, this has been in development for at least 50. I think the first stuff was coming out in 2005 that was being reported out. So worked on before then. So it's not new. It's not new. It's not like in March, suddenly someone pushed a button on the old mRNA vaccine factory and it all whirred to life and it was from scratch. Not at all. It was like, hey, we've been working on this for 15 years.
Yeah.
Here's a really good way we can put it into action. Let's just switch over to this instead of these drugs to these orphan diseases. It's the same as the ChAdOx1, like the chimpanzee adenovirus Oxford 1, the Chad, yes,
Chad.
This. Chad.
I know Chad from the SNL skits. I don't know Chad.
Chad. He's a good dude.
Hey, Chad.
Yeah, Chad, the pop collar. Yeah. But no, Chad is CH chimpanzee, AD adenovirus, OX Oxford 1. That's the virus scaffold for the AstraZeneca/Oxford vaccine. That was in development for a long time because they were making vaccines mostly to SARS-1, but to some other things too. But they already had it. They had the scaffold. They had this empty shell of a virus in which they can insert whatever virus they really were interested in. They can insert that nucleic acid right in there and just plop it in. They already had that shell and they already had tested it in humans extensively. They knew that it was safe, et cetera. And then when SARS-CoV-2 came along, they said, we'll just plop that right in there. And that's why from March, when it was really, taking off in the UK, to June, when they started the first trials, that's how you could go along at literal warp speed like that in 3 months because it already existed.
Yeah.
So as far as the people who are very concerned about this is so new, this doesn't seem trusted, this doesn't seem tested, it doesn't seem vetted, it has been, it really has been. Now it's true for sure, it hasn't been injected into millions and millions of people, but hey,
it has now.
It has now.
Yeah.
And we're all doing all right. I mean, look at Israel, right? Israel's got 80% of its population, eligible population vaccinated at this point. They're still kind of ticking along, right?
Yeah. And and doing extremely well.
Yeah.
Right. But they're seeing some breakthrough cases there, right? They're seeing, I think I'd read that 8% of their hospitalized patients were actually vaccinated.
And they're exclusively Pfizer. Israel is 100% Pfizer.
Interesting. I didn't know that.
Yeah.
So any final takeaways? Actually, I think we just covered the final takeaways. The fertility issue is one that I've grappled with. I've actually done quite a few episodes. For the listeners who haven't heard, I actually have, 8 episodes on how to talk about getting vaccinated with your patients, from someone who studies persuasion, someone who studies cognitive biases, legal issues, science communication, health communication, specifically discussing it with minoritized populations. I actually have 2 separate episodes where we covered that. So that I've covered quite a bit. The communication aspect we've covered quite a bit. But that specific issue about fertility is something that we actually, in all of those episodes, we didn't touch on. So that's helpful to know where it came from. It just came from one rogue post that was just wrong. But once that information is out there, you can't put the cat's out of the bag, the toothpaste out of the tube. You cannot put it back in. The damage is done.
Yeah, but that's where the toolbox that you just described, and that's fabulous that you've gone through that to such a thorough and wide-ranging degree. But that's where that comes into play. So you can stuff a cat back into the bag, even if the cat is really resistant. When you talk to people on their level and you're approaching them with respect, that's if you read this and you're not scientifically informed, how many of us really know about, even those of us who have read The Cell, how many of us really can say we know loads about protein stoichiometry?
I've been using stoichiometry wrong this whole time.
I mean, exactly.
Yeah.
So if I tell you there's sequence homology, and I use fancy words like this, sequence homology between the spike protein and the human placenta, and antibodies will cross-react. Well, that's plausible.
Yeah.
Isn't it? You're not nuts for believing that. You're not stupid for believing that. You're not stupid to be cautious if you're a woman who's thinking about getting pregnant or who is pregnant. So again, I mean, approaching people from a position of respect at all times, it's not something anyone would disagree on, but I think it can be variably put into practice.
Oh, and an episode on motivational interviewing. That was a really good one, using motivational interviewing to discuss vaccinations. But as what you're saying is, it just ultimately, you can get mired in the technicalities of it. You can get mired in the data. Ultimately, people don't use that to make their decisions. They make their decisions based on trust. And you can get them to trust you by empathizing with them, by acknowledging their fears, acknowledging their concerns, and having a frank discussion with them on their level, not being paternalistic, not speaking down to them, having a frank discussion. And even, I had some trepidations about getting it because I got the Pfizer vaccine before Moderna was even. I got it in end of December when it first came out. So there weren't that many people that were getting vaccinated. Was I a little nervous? Sure. It was this new thing. Who knows what would happen? And sometimes it helps for them to hear that. It humanizes me and it makes me a little more on the level where they are because they're having anxiety. So I think all of these things are helpful, but coming at it with empathy and humility and ultimately trying to restore their trust.
Yeah, absolutely. I mean, that's why things spread over social networks the way they do, because it's natural. We're, again, collective social herd animals, and we trust people whom we know, and we find trustworthy in other respects. So if your friend says something to you, if your college roommate says something to you, you might believe it a little bit more than some rando doctor who you think might have cross incentives, right?
Yeah, some agenda. But also, if it's a doctor that you've been seeing for a while, or a doctor that sees a family member of yours and you're going to, or it's a doctor that you know socially, and you're an accountant, you're a lawyer, you're not, right? You're going to have other reasons to trust them. So we can leverage that trust to help get closer and closer to herd immunity. Because ultimately, you're looking out for their best interests, whether it's your family member, your friend, your patient. You want them to get vaccinated because it's in their best interest. So it's not like you've got some nefarious agenda. Your agenda is you don't want them to get sick. You don't want them to get sick. And so leveraging that trust isn't taking advantage of that trust. It's just using your toolbox to help them as best you can.
What about bribes?
It depends, right? Like ice cream before my kids get or after my kids get vaccinated. That's the only way we'll be able to get them back to the pediatrician. So I think bribes are totally acceptable. I had to bribe my 5-year-old to eat a hot dog with ice cream, not together. He actually wanted to eat them together, but I said,
why he's got a discriminating palate. Good for him.
It was the epitome of parenting for me. I will get you ice cream if you finish your hot dog. What? Yes, those words left my mouth.
So here's the Gedanken experiment, though.
Okay.
What would you think if vaccine hesitancy still persists and there are pockets of a significant percentage of people that are holdouts? what would you think if a government, state or national, offered cash in exchange for being vaccinated so that we reached a herd immunity threshold and protected the collective?
I heard of nursing homes that were doing this. They were trying to incentivize their staff to get vaccinated to protect their micro herd.
Correct.
And so they were offering them cash. And I don't know. I'm not a bioethicist. I'm just an otolaryngologist with a podcast.
I mean, that's a longer word. That's more impressive.
Yeah. Otorhinolaryngologist.
Otorhinolaryngologist, yeah.
Yeah, technically.
They were the hospital where I trained. We weren't allowed to call ENT. We had to call them ORL.
Oh my God.
It was.
Get over yourselves.
It was north of you, if you want to guess where.
Yeah. Somewhere in Boston.
Somewhere in Boston, yeah.
Yeah. Yeah, sounds about right. It's like the internet meme. Tell me you went to Harvard without telling me you went to Harvard.
That's right. Yes. That's probably a good one, isn't it?
Yeah. You can't.
I'm going to consult.
It just bubbles out of them. You can't.
You can't do it.
People that went to Harvard can't tell you they went to Harvard without telling you they're dark because they just can't keep it inside. So yeah. So we lost track of.
No, I was asking you what you think.
Yeah, the ethical question.
Yes.
Compensating them.
And again, it's still a free choice, right? It certainly isn't a compulsory thing.
Yeah.
People can choose to come and get their $1,000.
Right. So the problem with that, I think, is similar to paying people to enroll in studies, because then it favors those who are economically disadvantaged. So then what you're doing is it's a study. So in studies, there are risks. This is not a study. This is out there. And we recognize that the benefits of getting vaccinated greatly outweigh the risk. However, that you get into the issue of then incentivizing those who are economically disadvantaged more than those who are economically advantaged. And I think there's an ethical issue there. But I don't know. Again, I'm not a bioethicist. That's an excellent question. Maybe we'll get Ezekiel Emanuel on here to wax poetic about bioethics.
That'd be cool.
That'd be cool. I'll give him a call.
Yeah.
Zeke. Me and Zeke.
Yeah, go ahead.
Jennifer Kasten, thank you so much once again. Maybe we'll do round 3.0 with the next pandemic. Hopefully there isn't one. But if there is, AstraZeneca's got their scaffolding. We've got the pegylated lipids ready for the next mRNA vaccine. We'll be guns blazing and ready to go.
Yeah, that'll be good.
Yeah,
the next podcast is going to be life after COVID, and then we'll just stare at each other. Yeah. What is there to talk about? If you can't talk about COVID.
You chopping down trees and building a bridge to get to the tree?
Yes. Yeah, we did that, yeah.
Yeah. We'll talk about that. I'm sure the listeners
It's easy,
would love
though.
to hear.
I mean, just pressure-treated lumber and a foot-long section of rebar and nail it into the ground. It's not too hard.
Yeah. The Jewish guy from Long Island, I don't deal with rebar.
But you built a fire pit.
I dug a fire pit and stacked some stones. That was the pinnacle of my COVID achievement.
Oh, it was rather a depression, actually. But
yes.
Sure.
Yes. All right. Well, once again, thank you very much for all of your time and all of your entertaining and educational posts. And I will definitely look for some reason to have you back on the show again.
Awesome. It was fun. Thanks so much, Brad.
Such a great show with Dr. Kasten. But before we end, don't forget to reach out to MR Insurance Consultants, where their goal is to assist physicians in obtaining the most comprehensive coverage available to fit their unique situation. Reach out for both excellent and quality service at drpodcastnetwork.com/MR Insurance or 800-817-4522.
That was Dr. Bradley Block at the Physician's Guide to Doctoring. He can be found at physiciansguidetodoctoring.com or wherever you get your podcasts. If you have a question for a previous guest or have an idea for a future episode, send a comment on the webpage. Also, please be sure to leave a 5-star review on your preferred podcast platform. We'll see you next time on the Physician's Guide to Doctoring.